Hello everyone, my name is Steve. I'm a licensed professional geologist. Geology is what I do, and I'm going to take you on a little tour of some earth science topics. I just want to give a little disclaimer first before I get started. You're going to see some definitions. The definitions I give you may vary slightly from what your teacher gives. I am a geologist. Geology is a part of earth science, but you are taking a more general earth science class, so there may be some variation. So go with what your teacher says, all right? I am here to hit the topics of your book. I believe your textbook has 8. I am going to cover all of those in 8 separate videos. This is one of 8. Around you here, what you see is this is something I built in my backyard. This is the GeoShed or GeoLab. I have the ability to run tests here. I have many rocks. Over here, I keep all my samples once they're studied. Any active stuff is either on the desk or in buckets on the floor. You're gonna see a lot of what is in here throughout the videos. There's gonna be a little bit of show and tell, and I'm gonna put that in here for you. But anyway, let's get started with the first topic. What are elements and compounds? So what are elements and compounds? Well, an element is a primary building block of matter that cannot be broken down chemically. Atoms make up the elements. What does that mean? Well, an atom is a basic building block of everything you see around you. We've known about them for a long time, but they cannot be broken down chemically. An atom has basically 2 parts. This isn't a chemistry class, so I'm going to gloss over it a little bit. You have in your nucleus, which is the first part, you can have protons and you can have neutrons. Neutrons have no charge. That's the green here. Protons have what we call a positive charge. That is just something we assign to them. So this is your nucleus, and this is specifically a helium atom. The abbreviation for helium is He. It is what we call a noble gas. That's its abbreviation. And around it, it has the second main part of an atom, 2 electrons. These are the blue. And those have a negative charge. And it's not as simple as this, but basically the electrons move around the nucleus kind of like this. It's not exactly what they do, but that's kind of like this. They exist in orbitals, so they're not exactly in orbits. So that's what an element is, and this cannot be broken down chemically. There's no chemical reaction I can do that can break apart this atom or element. I would need a nuclear reaction to break this apart or to put it together. Like when the sun does nuclear fusion, it takes 2 hydrogen atoms, which can just be protons, or a proton with 1 electron, or a proton with a neutron with an electron. Those are called isotopes. But the sun forces hydrogen together to form helium, and energy is released. In nuclear fission, we split atoms. We break apart the nucleus. Nuclear fusion and nuclear fission are not normal chemical reactions. Normal chemical reactions are things that happen in everyday life. As I eat food, I digest it, it gets broken down. That's a chemical reaction. I put salt in water, it dissolves. That's a chemical reaction. I put pure sodium metal into water, and a reaction occurs. It basically explodes. Those are chemical reactions, but even though you may gain or lose electrons, you can't bust apart this part. This is an element and an atom, and there are many that are man-made. There are many that are not, but that is a talk for another time. Before I get into compounds, elements and atoms can make up things you are familiar with every day. You're probably not familiar with this. Well, you are, if you've ever played with change in your pocket and pennies. This is a chunk of pure copper. It weighs just shy of 3 pounds. It's just under that, but it's not that big. Copper is, on the periodic table, appears as Cu. That's its symbol. And this is pretty much pure copper. But things can exist in compounds as well. A compound is something that consists of two or more elements. This is a compound. This is sand, and we're going to come back to sand later. Specifically, this is something in geology we call quartz sand, derived from a quartz arenite containing, well, quartz. We'll talk about that when we come back to minerals. So what are some everyday compounds? As it pertains to earth science and geology, there's many. Most are minerals, some are not. Ice, believe it or not, is not only a compound, but it is an actual mineral, water ice. And its chemical formula, we will get to these in a later episode, is that. Table salt, or what geologists call halite, is sodium and chlorine. Calcite is another common one, and calcite is calcium carbonate. Calcium, carbon, and oxygen. That is a compound. Quartz. Quartz is Si, silicon, and oxygen. Silicon dioxide would be what you call it chemically, but we call the mineral quartz. And there's a reason why we don't call quartz silicon dioxide like we do the chemical formula, and we'll get into that when we get into minerals, because minerals are chemical compounds or single elements that form crystals, and that's mineralogy, and we'll get to that soon enough. Now here on the board you see I have written sodalite. Sodalite is also another mineral. This is its chemical formulas. Chemical formulas are going to be the topic of our next video. As you can see, just get this out of this for now, it's very complex with a lot of elements all bonded together. I don't know the chemical name of this. I couldn't tell you if you paid me, okay? It's sodalite, all right? And this here is a piece of sodalite from South America. It's very blue, but it can also be white or white with tiny pinkish tint to it. And I bring this up now because you're going to see this again later, because it has an unusual physical property to it. And when we're talking about identifying minerals, that unusual property of sodalite is going to come back into play, and it does something really cool. Now, not all solid things are, not all compounds form minerals. When we get to minerals, we'll talk about that as to why. Like I said, here ice is a mineral, but most of you are familiar with it in its liquid water form. Water is not a mineral. Some things that almost never form minerals, unless they're really, really cold, if they do at all, are things like acids. This is one used to identify minerals. Hydrochloric acid, hydrogen and chlorine. It is made of one positive hydrogen atom and one negative chlorine atom. So I think that's all I'm going to say before I start getting into chemical formulas too much. So that concludes episode 1, which is elements and compounds, and I hope you guys learned something.